Let's have a look at this then. On indices, there's the base number and the index, that's what we call them. Don't usually use that terminology much, but that's what they are. 5 to the 4 then means 5 times itself 4 times. 5 times 5 times 5 times 5. This is just an abbreviated notation. So 2 cubed then would be 2 times itself 3 times. And we know that's going to be 8, for example. A to the n must be a times itself n times n. 3 to the 5, 1, 2, 3, 4, 5. Which is 243. Okay, so let's have a look at the first rule then, here. How do we get that? Well, 3 squared times 3 to the 4. Well, here's 3 squared, 2 times, and here's 3 to the 4. So how many times is 3 times by itself is 6 times in total. And similarly, so you can see that 3 squared times 3 to the 4, you just add the powers, don't you? So 2 to the 4 times 2 to the 3 we know is going to be 2 times itself 7 times. So you add the powers. And you add the powers, and that leads to the general, and this one here as well. 2 to the 4, and 3 on its own means 3 to the power 1. We often don't write the 1, but that's what we mean. So you can put the 1 in there, and it's 2, 6, 7, it's 3 to the 7. So there's the rule. Times you add is how we remember it with indices with the same base. Then when the indices are here, times you add the indices together. So let's move on to divide now. So 2 to the 6 over 2 to the 4, if you look at that as a long-winded fraction, there they are there. You can cross off or cut off 4 of the 2's, can't you, away from the top. So that would mean you're left with just 2 squared. So I hope you can see what happens here. Divide, you minus, top take bottom, 6 take 4, left with 2. Similarly here, 2 of the 3's will go away from the 5, so top take bottom will leave 3, 3 cubed, which is 27. 5 of the 10's will go from the 10 to the 7 to leave 2. 7 minus 5 is 2. So here's the general rule then, and you remember it in words as divide you minus, top take bottom, with the same base number and these indices here. So that's the situation there then. So divide you minus, top take bottom. So we can use that to work out these numbers then. So here, times you add, so you could do the add first, couldn't you, if you wanted, 6 to the 11 over 6 squared. And divide you minus top take bottom then. 11 minus 2 is 9. Or you could do it, just take 2 off from the 4 is 2, and then 2 and 7 make 9. Here, we can, that's a 1, isn't it? And 1 and 2 make 3. 8 minus, well, it's 8 to the 8. Well, you could cross off 3 of those to leave 1, couldn't you? And here you could cross off 2 of them to leave 6, and then another 1 of them to leave 5. So we end up with a to the 5 b cubed, using the rules for indices. Now that's the rule for, so we've done times and divide then, haven't we, and how that works. Now we look at 4 squared times 4 squared times 4 squared. You end up with 2 plus 2 plus 2 is 6. But 4 squared times itself 3 times is just 4 squared cubed, isn't it? So we could abbreviate that as this. And we get 4 to the 6. So can you see that power, 2 3's are 6. Power, you times. So that's the rule. When you have power, you times the two together. So with that thought in mind then, power, you times. 3 5's are 15. 4 2's are 8, so that's 8 to the 8. And then power, you times 8 to the 9. And then times you add is 8 to the 17, isn't it? Using the times you add rule. Now what is 8 to the 0? Well, if you look at 2 cubed over 2 cubed, you know that's 8 over 8. So you know that's going to be 1, because it's the same thing over the same thing, which is 1. If you use the rules for indices, it would be 2 to the top take bottom, wouldn't it? Would divide you minus top take bottom. 3 take 3 is 0. But you know that's equal to 1 then. So 2 to the 0 is 1. And it just turns out then that any a value of a to the power 0 is 1. And we've proved that with just the value 2, haven't we? So now we'll look at a to the minus m and a to the 1 over m and see what they are. Let's have a quick look at those. Okay, well I'm going to make some room now and go back up to the top and start again. So a to the minus m and a to the 1 over m. Okay, well let's have a look at this then. If we do 2 cubed over 2 to the 5, we use the divide rule. It'll be 2 to the divide your minus top take bottom. 3 take 5 is minus 2. But we know that this is equal to, if you cancelled, 3 of the 2's would cancel from here, so you get 1 over 2 squared, wouldn't you? So that's what we can see, that 2 to the minus 2 then is equal to 1 over 2 squared. So there's a to the minus m for you in general then, isn't it? That's what we can infer from that simple observation, that a to the minus m is 1 over a to the m. So you can bring out the indicial thing. You can flip it down underneath if you flip the sign, and you can flip it back up if you flip the sign. See the m and the minus m. The sign flips as you take it underneath, or bring it back on top, you flip the sign of the index. So for example then, 4 to the minus 2 would be 1 over 4 squared, that's what it is, which is 1 over 16. 5 to the 3 times 5 to the minus 5 times you add is 5 to the minus 2, because 3 plus minus 2 is 3 plus minus 5 is minus 2. And that's 1 over 5 squared, isn't it? Using this property, which is 1 over 25. So that's a to the minus m then. The next thing to ask ourselves is, what is a to the 1 over m? Well, let's have a look at 5 to the half. If we look at 5 to the half times 5 to the half times you add, so that would be 5 to the 1. So something times something equals 5. Well, that's the square root. So the square root of 5, another way of writing that is simply 5 to the half, because that's what it is. If you do the 7 to the third, by the same token, 7 to the third times 7 to the third then. Again, you end up with 7 to the 1, where times you add the powers. So you can see 3 things identical times together gives 7. So that's the cube root of 7 is 7 to the third then. They're one and the same thing. So 7 to the third is the cube root of 7. So a to the half corresponds to the square root of a. So 16 to the quarter then would be the fourth root of 16, which is 2. Okay then, so we know what it is now. A to the 1 over m is the mth root, isn't it, of a, because a to the half was the square root, a to the cube, 7 to the cube was the cube root, and so on. So a to the 1 over m is the mth root. Okay, so let's have a look at this then. 4 to the half is the square root of 4. 27 to the third is the cube root of 27 is 3. 2/16 to the minus 1/3 is equal to 1 over 2/16 to the third. And that's 6 cubed, so cube root of that's 6 then. So the way we could work that out if you wanted is the 4 is 2 squared. So write that as 2 squared to the half. And power you times, you get 2 to the 1, which is 2. So that's how you could get to it using properties of indices. This one, you could get to it as writing 27 as 3 cubed to the third. Power you times, that's 3 to the 1. And here you can write 1 over 2/16. So that's 1 over 6 cubed to the third, isn't it? Power you times, and you get 1 over 6. Because 2/16 is 6 cubed. So that's what that is then, in terms of those examples. So, last little thing to note is a to the k over m. Yeah, so what's that then? Well, let's use the properties of indices. It's a to the 1 over m to the k. So you could think of it as the mth root of a to the power k. Or you could think of it as the a to the k to the 1 over m, couldn't you? Because that's the same thing. So that's the mth root of a to the k. So this is what that means, from what it is. So let's have a look at an example then to see what we're talking about. 4 to the 5 over 2. Well, here, if you wanted to work that out, you could write that as 4 to the half to the power 5. The square root of 4 is 2, so that's 2 to the 5, isn't it? Which is 32. Okay, good. And then 16 to the minus quarter is equal to 1 over 16 to the quarter. which is equal to 1 over 2 to the 4 to the quarter, isn't it? Power u times, it's 1 over 2 to the 1, which is 1 over 2. Let's have a look at one or two more, just to finish off. 27 to the 2/3 is equal to 3 cubed to the 2/3, isn't it? That's 27. That times that will be 3 squared, so that's equal to 9. Okay, good. And then the last one, a squared times a to the 3rd over a root a. So here we could let's just do the powers times you add a to the 2 and a third, because times you add, and underneath you've got 1 and a half. So that's a to the 1 and a half. So you've got 2 and a third. So you better write this as 6, haven't we? So we've got 13 over 6 over a to the, and this is 9/6. Okay, that's 2 to the 4/6 when you take them away, which is 2 to the 2/3. Well, I don't know why I'm writing 2 for. It's a. Got distracted here, haven't I? It's a. Oh, hang on. I'll get it right in a minute. Oh, we can change it. 3 over 2. Oh, let me work this out again. I might have got this wrong. This is 7/3, which is 14/6. Helps if I know fractions, doesn't it? And that would be 5/6, and it's a. A to the 5/6. There we are. That's a bit better. So I got lost on the fractions there. Because 7/3 is 14/6. There we are. And that's 5/6. Okay, so that's the indices.